Welcome, everybody. My name's Greg Brown, and I work in Onshape's product management team. I'm really glad you've been able to join me here today in this session as part of our first ever Onshape Users Conference. So I'm going to be sharing with you a few, actually quite a few, tips and tricks that I've learned during my first year or so of Onshape modeling experience. Now, these are not just necessarily new features. In fact, some of these might be quite old, but they're all extremely useful things in helping you build better models faster. And remember, there are a ton of great tips and tricks videos on the Onshape Learning Center, so I encourage you to check them out, as well as sharing your own tips and tricks on the forums. Now, there are literally hundreds of tips I'd like to share today, and I'll get to as many of them as I possibly can. But to keep things on track, I've grouped the tips into these top 10 themes. I've also got a cool set of documents I want to share with you along the way. So let's get started and let's get organized. Now, it's easy to be organized in Onshape and the benefits are great. Remember, Onshape is built to be collaborative. So you should utilize these tips to make sure that others can easily understand what you're doing. Now, incidentally, these tips would all be perfectly applied to those who submitted entries to be judged in the Onshape design competition. I'll come back to that a bit later. But even if you work alone, these still apply and will make your life easier. So let's move over to Onshape now and take a bit of a look. Now, right from the start, in your My Onshape page, there are some things that can make your daily life easier. I love to use labels all the time, multiple labels on my documents. Onshape lets you navigate between these documents and group them together simply by clicking on these labels. And let's talk about naming. One thing I love is that since Onshape is a modern application, it allows for proper naming of everything, long names, capitalization, spaces, even apostrophes. It's amazing how this really helps bring things to life. There's really no excuse to having long lists of features called things like extrude 1, extrude 2, extrude 3, and so on. So go on, take the extra few seconds to name things properly, and you will not regret it when you and others come back to edit. Now, going a bit further, the ability to put groups of features into folders, which of course you would properly name, right, really helps keep things neat. Now, this is particularly useful when you have a multi-part studio like this one. I group the features that belong to a specific part together for easy reference. Now, a side benefit is if you have long lists of features in a part studio, like this one has something like 350 features, then you can easily scan down to see if there is a failed feature in any of your folders. The other aspect of folders that deserves its own tip is that folders encourage you to model things in functional units. Even with something like this carburetor casting part, which is a single body, certain areas of it do perform specific functional tasks. So it makes sense to keep those features grouped together in a folder. The next thing is that variables are a perfect way to organize your part studios too, right from the start. High-level requirements or driving influences can be captured in a variable and reused in whatever sketch or feature or features need them. Of course, you can configure variables too. One last organizational tip I want to offer is to embed verifications right into your feature tree. I'm using a great custom feature here called Sensor, and that gives me an instant visual check on whether a key characteristic I'm trying to track, such as the volume of fuel, which will fit in the fuel bowl of this carburetor, is meeting my requirement of 65 cubic centimeters. There's a few tips for organizing things. Now, next up, let's use a little bit of Boolean magic. Now, Boolean tools in CAD are about as old as CAD itself, but their usefulness is undeniable. Again, let's go and take a look inside Onshape. Recall that I talked about grouping features functionally in a previous tip. Now's the time to see why. By grouping the features that make up, say, the choke function in this carburetor, and also by keeping them as a separate body for the time being, I can perform a Boolean operation to remove this whole chunk of geometry from the final casting. Now, a bonus tip here is to use the Keep Tools option, which lets me visualize these fuel or air pathways more easily. Now you can see I've used the same technique on a number of different functional areas, air bleed circuits, fuel delivery circuits, and so on. And having all these visible, especially with the translucent view of the casting, really helps me communicate the design. Now they say that you only get one chance to make a first impression. And since CAD is a visual medium, it makes sense to use all of the Onshape tools at your fingertips so you can make a great first impression. Let's go back into Onshape and take a look. So back here on the My Onshape page, I can take control of the thumbnails that are shown. In the document of my choice, I just right-click on any element and select as document thumbnail. It's as simple as that. And now for the creative part. This element could be the top-level assembly, or a drawing, or a part, or even an imported or rendered image like this one here. When your design is reasonably complete, or you know what it's going to look like, then having these realistic images as the thumbnails, looks great. Now, setting face colors is a great aesthetic improvement too. Over here on my temperature gauge, I've split the screen with a sketch containing some text, and I've assigned colors to these split faces. And remember, these appearances can be configured too. So I'll let your imaginations run wild with the possibilities there. But my additional tip today is to color things via their utility. Things like machine faces, threaded holes, or other functional things like air bleed passages, or fuel feed passages. This really makes things a lot easier to understand for yourself and to communicate to your collaborators. You'll see here there's a little bit of a theme already developing about communicating your ideas to your collaborators. And continuing with this visual theme, let's talk about creating animations. Personally, I think that if it moves in real life, then you should see it move in CAD. So here are a few of my tips for doing just that. Okay, when you create the mate in the first place, you should try and set appropriate limits on its range of motion. Now, it's never too late to go back and fix this if you forgot to do it, but it certainly helps if you can do it up front. The benefit is that you'll see these limits get applied automatically when you use the animation dialog. Next, make sure to choose an appropriate number of steps for the animation. I like to start with numbers around 30 or 40 or 50, so that the full range of motion takes about a second on my laptop. Now, you might have to experiment, and you should go and do that. Now, also, you can choose the right playback type, whether it be reciprocate, single shot, or loop, depending on the type of mate. And for linking the motion of one or more of these mates, you can just use constraints like gear, linear, rack and pinion, and so on. In this example here, there are a few that are linked together with gears. And if I combine all those tips in back end together and use 35 steps, then I get a really nice, realistic looking animation here. Now, you know, a picture might be worth 1,000 words, but definitely an animation is worth at least 35 pictures per second. Now, making selections is a natural part of your CAD life. And there are a few things I want to share about Onshape in this regard. If you ever find yourself doing numerous pick to select all the things you need, trying to get the edges, having to zoom in, zoom out, pick the wrong thing, then you should stop until you check out the Create Selection tool. You can access Create Selection anytime through the right mouse button. Just choose the appropriate rule for gathering faces or for gathering the edges, and it will automatically grab the things you need. For example, here, I'm going to grab the fillets of an equal radius, and I click one fillet and it will grab all of the other ones with it. So there's 6 there now. Alternatively, I'm going to use the tangent connected edges, collect one edge, and there we go. But my very favorite tool or option here is the bounded faces option that I can use to great effect on my next document here. Now, this mountain bike shot that I'm going to show you is pretty complicated, and I'm going to cut through it with a section, and you'll see that there's a lot of things on the inside. Now, I want to gather all these faces, perhaps to create a volume for some sort of analysis. So I'm going to use my bounded faces tool as part of the create selection option. I'm going to create the selection. I'm going to choose the first face, and then I'm going to choose the bounding faces. And what the system does is collect everything that's in between, all 201 faces in one go. I'm going to drop that selection now into my offset surface tool with a 0 offset. So basically, I've copied all those faces and created one new surface. If I turn off the solid, you'll see that surface there. And I'm going to just fill in those openings on the end with a fill tool. On one end there, I'll go up to the other end, use the same fill tool. And once this is a fully enclosed volume, we'll have a solid part. I'll just cut through it, and you'll see, it's a complicated part that we've created in a very, very short amount of time. Now, incidentally, I really like to use this technique of creating the selection and then dropping that into my feature. It works for me. Maybe you should give it a go. Now, we all start somewhere when learning a new CAD tool, and it's easy to get stuck in the routines that you first learn when you pick up these new workflows. But these standard routines can require a significant amount of navigation through the UI, which can add up to lost time. Now, interestingly, a subculture around gaming where people compete online in speedruns has recently spilled over into the CAD world. If you do a YouTube search on this, you might find a user of Onshape called Alnos Smidgens doing amazing things in this CAD speedrunning world. And in fact, I consulted with Alnos before this presentation and convinced him to share a few of his secrets. And here they are. The shortcuts toolbar and keyboard shortcuts are great places to start. The Part Studio, assembly, and drawing environments have customizable shortcut toolbars, which offer immediate access to your commonly used or favorite commands in each of those environments. And once you start using them, you'll never go back. Just keep your left hand near the S key, and you're off to the races. You'll see here that I've got some of my favorite there in my shortcut toolbar, maybe the offset faces, the bridging curve, the fill tool, and my old mate, the mate connector. Also, did you know that in many cases, there's no need to actually select an object to carry out a task? You just hover over the object, and then there are numerous keyboard shortcuts, such as create sections, things with visibilities. Also another one with translucency, you hover, Shift T, or hover and N, give it a few normal. Each time saves a few clicks, but it adds up over the course of a whole project. As an extra bonus tip, I use a gaming mouse because it has a bunch of extra buttons on it that I've mapped to common tasks like things making transparent or hiding a part. Now, this is one of my secrets for an Onshape speedrun. I also use a bunch of silly mnemonics to remember the keyboard shortcuts. One of my favorite ones is, why are you there? And that will hide a part. The other one would be, hey mate, to show the mates. And if you're ever doing an assembly, assembling things together and things seem to be flipped, then you just yell out, ah, which is the A key, and it will flip it on its axis. So go ahead, experiment with those sorts of things. Now, feature script is also useful for speedrunning. It was a programming language we designed and used inside Onshape for building and working with part models. And it was built into Onshape from the ground up. Feature script can be used to create custom features that sit alongside our standard Onshape features. I've got a bunch of these shown in my toolbar at the moment, some of my favorites, including the drivetrain generator, which I tend to use a lot because I like things with gears in them. So go ahead and experiment, find your favorites, and then add them to your own environment to make things run fast. Finally, if you ever need to troubleshoot models with long regeneration times, then the regeneration time tool can be used to diagnose the performance of every feature in a Part Studio. I can trace exactly which of the features is causing the longest delays, and then maybe take steps to perhaps do things in a more efficient way. It gives a really powerful insight. It's also really easy to use. Powerful, easy, why not both? And talking about assemblies, the right way to use them and to gain the most benefit can easily take up the rest of today. But with only a few minutes here, I'm going to focus on a couple of key issues. As mentioned previously, though, there are a large number of great technical videos that you can view at the Onshape Learning Center, so I encourage you to do that. At the end of the day, pretty much everything we design consists of more than a single part and needs to be assembled, and Onshape's mates are used to do that. Onshape's unique method of mating components means that parts that may have needed 2 or even 3 separate constraints in a traditional CAD might need only one mate in Onshape. The secret to Onshape's mates, of course, is the mate connector. Now, as an Australian, it's natural for me to be proud of my mates and also my mate connectors. There are also a number of novel uses for mate connectors outside of the world of assemblies, such as references for cross-sections, perhaps when a situation arrives where there's no convenient cylindrical or flat face. The other thing you can do is use a mate connector to define a sketch plane. Now, why on earth would you do that, you ask? Well, there's a couple of really good reasons. And the one I want to focus on here is that it's really, really easy to reorient a mate connector, like I'm doing here at a new 60-degree angle. I can do that reorientation without having to create additional complicated construction geometry in the sketch. Now, when you've got parts that make up a subassembly that are already in an as-designed position, perhaps you've built all these parts in a single part studio, or you've imported from a third-party CAD file, or you've designed in context part studio, then the group, which is a special kind of mate, can be utilized so these parts behave as a rigid unit within the larger assembly. My tip today is to use groups early and often when you have such parts that do not move relative to another. You can always edit that later, but initially it helps to keep things together. And I'll show you another example of that in the end. And speaking of in-context modeling, this tool might just be my all-time favorite in Onshape. There are a bunch of uses for it. Obviously, it can be used to design new components or sub-assemblies within the larger context of an assembly where they live. But it can be also used for other design challenges. For example, here, I've used it for creating cutouts on the floats of this carburetor, and it goes through a range of motion, so I need to see it in all different configurations. I can also use it to design piping, perhaps here, and from the bottom of the fuel bowl of the carburetor up to the top of the casting. So there's a pipe there in the context of that assembly. Yeah, there are a great number of other things. I could use it to help design wiring. I could help it to design tooling around my components, or perform maybe advanced geometric measurements in the assembly. The list is really endless. So in-context modeling is a really powerful weapon in Onshape, and you can use it and learn to put it to your advantage. Now, I think we can agree that 2020 was a bit of a year to forget for many reasons, but for Onshape drawings, it was a highlight. Our drawing environment has seen significant enhancements over the course of the last year. And just looking at this little image that I've dropped into my document, it's cool how you can do that, right? I see improvements such as direct min-max dimensions, addition of alignment tools for broken views and projected views of sections, as well as updates across the board with regards to whole tables, revision tables, and custom tables. It's never been easier to make drawings consistent with your company's standards. Let's take a look. For parts like this, where they've got a large number of drilled holes, a hole table is frequently used to provide the locations of these holes with respect to a common datum. Onshape's hole table goes a bit further than those you find in other CAD tools, and it provides cross-highlighting between the holes in the hole table and those in the drawing itself. I can highlight, for instance, all of the 2.8, 7mm holes, 2.4mm holes, or maybe individual holes like designated C2 or C1 here. The revision table is another area of Onshape provides some almost unparalleled functionality, especially with the display of revision-specific callouts right in the field of drawing. As subsequent revisions are released, the visibility of these drawing callouts from old revisions can be suppressed depending on a rule that I set up. Finally, collaboration through Onshape has been enhanced to include the ability to attach markups in the comments section. Now, the big tip here is that it works really well for drawings. Once active, markup takes a snapshot of the current drawing and enables users to add notes, callouts, and other scribbles, which they can be shared directly with the users tasked with editing the document. It's powerful, extremely useful, and really simple to do. And speaking of collaboration, I've set this document up so that I can easily share it with people as a view-only document simply by using this link. There's no need to have them have any special software or any special plugins, just a web browser. Now, let's pause for a second for something a little bit different. Now, I was involved right from the start of PTC's acquisition of Onshape. And early on, I was asked by somebody to describe Onshape in as few words as possible. I told them it's fearless CAD. Now, let me explain. When you remove the need for files or installs or any upgrades or license management, when you can work seamlessly across multiple devices on a train, remotely, at home, or in a cafe, when you have the safety net of forever undo, and when you cannot and do not ever lose any data, when collaboration is a seamless experience and it actually encourages you to use it, and when branching and merging is simply foolproof, then you find it really opens your mind to being more creative, to be more agile, and to take risks with big changes. The kinds of changes that would have typically meant warning your desktop software colleagues and having them make file save as copies onto hard disks just in case. No, you find yourself in a fearless CAD zone. And as a result, you could be way more productive and enjoy the process at the same time. So my tip here is to embrace changes, to take risks, to get creative, because Onshape always has your back. Now, in the tradition here of all good tech conferences and presentations, here's a few more one more things. My mouse over here. Did you know that if you have an iOS device like an iPad or an iPhone, that you can use the camera to directly import an image into the document that you're working on the Onshape app? You'd simply take the photo, you can see it now there as an element, and I'm going to start a sketch, and I'm going to use that image and select that image and put it in the background of my model. Now I'm going to look at that now back here in Onshape, and you see here I've got my photo import. And what I've actually done is trace a few lines over that to start the form of the sketch. And of course, what I could do is now just select some of that parts of the sketch and create a feature which might be the basis of a PC board. And of course, following my own tips and tricks, I'm going to name this feature carefully. The first rule of CAD Club is to always name your features. So now I've got the beginnings of my design, and it's just incredibly handy to have this automatic way or easy way to bring things into the model. Now over here, I'm going to use one of my favorite features on Onshape. Now, I'm not sure how the performance looks across the live stream, but here it's pretty slippery. In fact, it's so slippery that this has just fallen out of the screen on me. So I used this model, which was the first thing in front of me on my desk when I started preparing for this conference, to create this for you and to test all of my theories. One of the things I did want to show you with this is the whammy feature. Actually, it's called the isolate, the isolate tool, but I like to call it the whammy. And the reason of that is that, I play the electric guitar and I'm no Tom Morello, but I do like a good whammy pedal. And so when I hit the whammy pedal up here, what happens on the Onshape screen, you can see why I call it that, and why you too can be rocking out with Onshape. Now, you might remember this document that I started showing you early on when I talked about mates and groups. So just to review, I imported this from a third-party CAD system And I started grouping things. Now you see I've got a couple of groups here, one group for that, another group for the stylus. And then I added a couple more mates, so that the needle would move and this needle would move. Then I added a couple of constraints. There's a rack and pinion constraint to turn the motion of the stylus into motion of the pointer. And I thought that was pretty cool. And in fact, you end up with something that has the exact same resolution of 0.01 millimeters. Each one of those gradations is 0.1 of a millimeter. So that's fun. And really what I've ended up doing is creating an analog sensor from this digital process. But that's not enough. I started thinking about some of the other models and other documents that I've been creating. Over here, I'm going to start with my whammy tool again, my isolate tool again. This is a crankshaft that I'd been working on for some time. Now I'm going to use a cross section here in addition to the isolate tool. It's cool how you can do two of these things at the same time, right? Anyway, I started with the crankshaft and I added two of these measurement devices, these dial indicators, including the measurement stands. Then I went on and created the frame. Now, the way that I created this frame was using an in-context part studio, using a custom feature also, which allows me to build these standard frames, such as this 80-20 section. Anyway, you can see how this model is building up and up and up together. And the final test of this was to get it all going in an animation. So again, I'm going to use some of my own tips that I've been sharing with you today. And this time 55 is the fastest thing for me to type. And I'm going to set this moving. And you'll see how my analog sensor is measuring the run out of this very wobbly crank. It's deliberately run out so that it would actually show you in this demonstration. But you can see here, it's just an example of being creative, taking a few risks, bringing things together, and having some fun at the same time. So as I mentioned at the start, I could really only cover a few tips. I think by count, maybe there's 45 of them I've shared with you today. But there are many more such presentations available on our website and on the forum. So I hope you get a chance to check them out and contribute some of your own. But in the meantime, I encourage you to get creative, to try some of these new things, take some risks, and be fearless with Onshape. Thank you very much. So I'm going to wait here and see if there's some questions coming in. In fact, I think there are. I'm just going to have to get the live feed up on my screen and start trying to get to some of these questions here. So there's one question here. Does Onshape have any surface modeling tools? Now, old CAD has an entire menu of surface modeling tools with with equivalent commands in solid modeling. I can't seem to find these in Onshape. Yes, in fact, Onshape does have these surface modeling tools. It's just that you might not have seen them because they're combined with the solid modeling tools, in fact. So everything like an extrude or a sweep or a loft will have a solid or a surface feature option right there in the same dialog box. Just look in the dialog, you'll see that there. And you'll see some of the options will change when you choose the surface option. There are also, just remember another thing, there are also a lot of interesting and powerful tools. I mentioned one of them earlier on. It's in my Part Studio shortcut toolbar, which is a bridging curve. Now, bridging curves are really useful for creating boundaries, which you can then use to put the fill surface tool. The fill surface was something else I showed during the demonstration as well. So those things tend to work together. So in addition to the ones at the beginning with loft and sweep and extrude, there are a number of other tools that you can find in there that help you build or repair surface models. Next question here. Is there any facility for performing multi-user design review? Absolutely, yes. In fact, Onshape was built on the kind of foundation capabilities that allow this and are so difficult to add later on into applications. Onshape was built on this platform for collaboration. Documents can be shared really, really easily and quickly via that link, maybe that I showed you with the drawing. Maybe you can just invite other people in your enterprise to do that. And it's a super, super easy way to do that with a client or a partner or someone else in your company. So yeah, multi-user design reviews are a fantastic capability. And yeah. Next question here. Does Onshape support data export for 3D printing? Yes, Onshape supports a number of different export formats, commonly used in 3D printing world. Things like STL, probably the most popular one. Some people also use OBJ format or a newer GLTF format. And typically what happens today is that different printers use different slicer software, which often takes care of things like supports inside the slicer. So Onshape supports, creating the geometry that would then be, imported into that slicer software. There are a number of partners that you might want to check out in the App Store as well, who have specific setups for 3D printing. Are there any visual cues for users as to whether or not a sketch is partially or fully over-constrained? Right? Yeah. In fact, when you are sketching in the sketch environment, you'll see things are changing colors, changing colors on you. First, unconstrained things are in a blue color. So you'll see vertices or lines in a blue color. That means they're still unconstrained, and you can drag these around with your mouse. As you start to add constraints, they'll turn black, and the black means it's constrained. So if you add dimensions or you add other types of constraints like coincident or tangent, things will start to get black. Now, if you over-constrain something, there will be a message, a warning that sort of constraint cannot be supported, and things will turn red in there as well. So you get a chance to fix that. There is also a checkbox in the sketch dialog that you can use to look at all of the constraints that are currently on that sketch. Right, trying to get through this next series of questions. Is there a way to set my view normal to a face or plane in Onshape? Yes, there absolutely is. And in fact, it was like my tip number 32, something like that. It was one of my favorite tips. So you can hover over any planar face or plane and just hit the N key, right? And then that puts you normal to that plane. This reminds me that there are a lot of keyboard shortcuts, and hitting the Shift ? Key will bring you up. That's the first keyboard shortcut that you should learn. It's kind of meta because it teaches you all the other keyboard shortcuts. All right, how are we doing here? We generate a large number of document drawings which have standardized number and arrangement of views as well as standard general notes. Is there a way to generally quickly accomplish creation of drawings with Onshape? Now, making a drawing template, that's what you want to do. And it's pretty easy. You can apply it every time you start a new drawing, or you can go back and replace the ones that were there before. So in addition to those things you talked about there, I think orthographic views, standard of general notes, dimension styles, text styles, projection types, all of those types of things can be captured in this template and very, very quickly reused. All right, I think we're nearly getting to the end here. There's a couple more. So the CAD product we're currently using has very good support for table-driven families of parts. Is there a way to accomplish this with Onshape? So yes, of course. At Onshape, we rethought the whole approach to tables and configurations. It's something that's got a lot of legacy in different CAD tools, and we've seen a lot of problems build up from that. So we wanted to take a whole new, fresh approach to this And we did come up with a more flexible, faster way, I think, to achieve what you need. It's probably, that's the subject of a whole seminar that we could do. And I know for a fact there are some technical tips, videos on the Learning Center, particularly for this topic. So maybe you could check them out and see how this works, because they are much more efficient than things from the past. Right. I think probably have time for one more. So our company works with other companies and divisions that use a variety of CAD products. We need to be able to integrate their data into our design work. Is this possible with Onshape? Absolutely, yes. So Onshape supports standard 3D formats, such as, of course, the native Parasolid format, but also STEP and IGES, as well as other native formats, such as Creo, SolidWorks, Inventor, CATIA, and NX. And we also have a nice way to update these imports should a new version of that third-party CAD file become available. And we do that and still maintain references for any features that you may have subsequently added on the initial original import. So that gives you a way to kind of update and keep things in sync. I think that is the list of questions that I've got here. I'm not seeing any others in my queue. So maybe I will just take this moment again to say thank you. I know that I went through this in a sort of a rip-roaring pace, but that's the sort of thing, there's so much new and so much great stuff to share in the Onshape world. I hope we can do a lot more presentations like this in the future. And I hope you can check out all the things that are on our Learning Center, on our website, on the forums. Google around, you'll find a lot of stuff on Onshape nowadays. And hopefully you can start to contribute some of your own, especially on the forums. So again, get out there, get creative, try some new things, take some risks. Remember, be fearless with Onshape. Thank you very much.